Hey everyone, I'm trying this out. I'm holding my phone, and I don't know how this is going to work, but I'm going to try to explain the way Don has been teaching everybody or showing everybody like this new way of like not using those complicated formulas. Well, I think they're complicated. Some people love the formulas, and if you love them, if it's working for you, I would stick with it. I wouldn't change. But then there might be some people that's having trouble with all these formulas because, like me, I cannot learn all them formulas. I don't know them. I learned 3 formulas, and I've used 3 formulas the entire time I've been in the program. So I've kind of got used to, knowing what to do and how to use them. Those 3 formulas, I'm going to write them right here, are, this is weird trying to look at the screen and look at the paper too. I'm just going to look at the paper and hope I'm doing this right. 3 formulas I use are A times B divided by C equals D, or A times B divided by C squared equals D. That's the one I use for distance. Anything that involves distance. Or, there's some times where you might get like here you're having the 2 distances, like 40 inches or 72 inches. And then this would be like millirad, or this could be like mass. I mean, this A could represent a few different things. And there might be times where, like, you say you have so many milliroentgen exposure at 40 inches, and then, like, say 10, and then there's a 40 milliroentgen exposure at what distance? So they're wanting you to solve for a distance. And that gets a little tricky, even with your formula where it says I1 over I2, I think that's the exposure one, I don't know, equals distance over something and distance over something. Whatever that formula is you guys use, you still have to end up figuring out the square root whenever you cross multiply, I think. So my third formula is the square root of A squared times B divided by C equals D. Times, this is times. These are kind of dark because I think that one looks okay. So those are my 3 formulas. And this is A squared. That's going to be a distance. And I'll show you in a minute like how I'm going with this. The most important thing to know when using these formulas is this. You have to know what needs to happen. And I think this is the most important thing to know if you use any formula. Any formula in our class, you should know what the outcome should be. If you increase your distance, you have to increase your mass. If you increase your grid ratio, you have to increase your mass. If you increase KVP, or you increase the screen speed, or you increase transformers, which this one we haven't really gone over too much, so I'm just going to leave it out, you would decrease your mass. If you decrease your field size, like collimating down, you would increase your mass. Okay? These are things that you just need to know. Like, they should be in your head. You should understand why all this stuff happens, why you have to increase your mass for, like, when you increase your distance, like why that happens. Same thing with grid ratio. I mean, don't just know this. Don't just like study that you need to do this when this happens. I mean, understand why you have to do it. Do all that you can to understand. Do all that you can to understand. I like that. Anyway, so here again is the formulas. And I'm going to go over these here in a minute. We're going to do this equation, which basically has all that in there. I kind of just made it up, but it's all there. Now you can go through like we have been doing, like he's been showing, like do one step at a time, go to this step, do this step, or you can use your calculator and just do it all. And let me explain to you what I mean. So we're going to start here at 25 mass, 60 kVp, and then all this stuff. But we're just going to concentrate on this kVp, okay? 25 mass, 60 kVp, what mass at 70? So we're increasing our kVp, we need to decrease our mass. By the 15% rule, it's like cutting your mass in half, okay? So where I would start is 25 in my calculator. Then I would probably do it like this with some parentheses, divided by, we only have one jump, okay? Now, this may confuse you, it may not. Each jump gives you a number 2. So if you do one jump, it's divided by 2. If you go from 60 to 70, and this was actually at 80, and it was 60 to 80, that's 2 jumps, then this would be a number 4. And it would give you the exact same thing as doing like 1 and getting to 12 and a half, and then doing another half, which would give you 6 1/4, I think, 6.25. If you just took 25 divided by 4, you're going to get 6.25. So each 10 rise in kVp, you would divide by 2. Now, if it was the other way around, if you dropped, it would be like doubling, so it would be times 2. This would just change to times if you went from 70 to 60. But since we're going up and we know this needs to go down, we have to divide. You have to divide to get a littler number. If you was going from 70 to 60 and you knew that this would need to go up, then you would times by something to get a bigger number, if that makes sense. So we only have one increase in one 10 kilovolt increase in kVp here, so we're just going to stick with the 2. Okay, and I'm going to bring my calculator over here and try to get it in. So I have, this is going to be weird. Let me redo it. So I have right now, I'm using my parentheses. I use parentheses for everything I do. 25 divided by 2. Okay. And then I'm going to get ready to do my other parentheses. Now we're going to go to the distance. That takes care of that, which you know this is going to be 12.5. I mean, you can do it separate if you want, but I'm just going to put everything in my calculator and get to the end. All right, so we're at 40 inches. We're going to 72. Now this one here is using none of these. It's just starting off getting your kVp out of the way. Then we're going to have 12.5. And then again, we're only using, so right here would be 25, and then it would be divided by 2 to get that one. Now we would have 12 and a half. That would be A. 12 and a half, and then, well, it would be using the distance one. I'm using this formula. My distance, whatever distance goes in here, squared. Now I'm at 40 inches, I'm going to 72. So again, you have to know if you increase your distance, you have to increase your mass. So this is going to be an increase. We need this to increase. And the way you do that is by, if you need an increase, you put the bigger number on top. And if you need a decrease, you put the smaller number on the bottom using these formulas. So this one here is going to be the bigger number, and this is going to be a smaller number in this situation because I need the number to get bigger. So 72 divided by 40 squared. Okay, I mean, you could put it in the calculator, 72 squared divided by 40 squared, if you want to do that. My handwriting kind of sucks. But I'm just going to do it like this because it ends up being the exact same thing. So I've got 72 divided by 40 in parentheses squared. Get my parentheses for the next one. All right, now we're going to grid. Again, I can't stress enough that you have to know for these formulas that what has to happen and where you have to arrange the numbers. If you want an increase, if you need to have an outcome where the number's bigger, you put the bigger number on top. In any situation here, any of these formulas, you're going to put the bigger number on top if you need a bigger number. And you have to know this to know what you're going to need afterwards. And then the smaller number here. If you need a smaller, say if we was going from 72 inches to 40 inches, if it was flipped around, I would need a smaller number. So I would want to put the 40 inches on top, the smaller number on top, and the bigger number on the bottom. So just know if you need a bigger number, the bigger number goes on top. If you need a smaller number, the smaller number goes on top. All right, so then we have another parentheses, which is kind of hard for me to write and look at this. We're doing grid now. We're past all this. We're moving on to the grid. So on the grid, we have a no grid to an 8-to-1 grid. Again, if you increase your grid ratio, you increase your mass, right? So we started with a grid number of 1, and 8-to-1 is a 4, right? I know that I need an increase in mass because I've increased my grid ratio. I've increased it. So I need the bigger number again to go on top. Well, this has a 4. This has a factor of 4 to an 8-to-1. So it would be 4 divided by 1. And then I would put that in my calculator. 4 divided by 1. In parentheses, start a new one because we're moving on. That takes care of that. Here again, we have 100 screen speed. We're moving to a 200 screen speed. All right. Now we know that when you increase your screen speed, you decrease your mass. Okay. So this is telling me that if I need a decrease in mass, I need to put my smaller number on top. I need a smaller number to get the outcome, smaller number on top. So you can either put it as 100 over 200, or since they're hundreds, just 1 over 2 is what I do. 1 divided by 2. Boom. So I'm going to put this in my calculator. 1 divided by 2. In parentheses, start parentheses. All right. So now that's taken. Let me go back over here. We went right here. This was the KVP adjustment. This one was the distance. This one was the grid. This one was the screen speed. The only thing we have left is the collimation. All right, now this has to do, let me get my finger out of the way. I don't know if this is tripping y'all out. I'm probably shaking. We're going to decrease the field size from a 14 by 17 to a 10 by 12. If you decrease your field size, you increase your mass. When you collimate down, when you go from a bigger field size to a smaller one, you need to increase your mass. So, when you decrease your field size, increase your mass, so we know that we're going to need a bigger number here. Now, this has a factor, if you guys remember, if you go from 14 by 17, it's 0.25, or 25%, or if you go from 14 by 17 to 8 by 10, so to 8 by 10, it's going to be 40%. All right, but we're doing the 25%. What I do here is if you take this times 0.25, it's going to give you a number, and then you have to add that to it, right? You have to add that to whatever number you're going to end up here. I just take these factors and I put a 1 in front of them because I need whatever I have times 0.25. So if you times it times 1.25, we're going to arrive to our final number. So let me put this inside here. Times 1.25 in parentheses. And here it comes. Are you guys ready? Bam. Oh, there's the mass. 101.25 mass. And that's it. I mean, I know that looks complicated, but it's really not once you understand it, because like I can do this thing in about, I don't know, maybe about a minute, maybe not even that. I put it in my calculator and like, I don't know, however fast I can write it, because I understand what's needing to happen here. Again, let me explain this one here that might kind of confuse people. Let's say if we have 25 mass, this is messing me up, I'm not going to lie, at 60 kVp, what mass at 80 kVp? Okay. Well, in the calculator, I've went up 2 times. I went from 60 to 70, then from 70 to 80. That's 2 jumps. That's 2 tens, okay? 60 to 70 is one 10 kVp or kilovolt change, and 70 to 80 is another kilovolt change. That's 2 changes. So I would just put 25 divided by, there's 2 changes. Each change is 2, so divided by 4. Because this first one was going to be divided by 2, and then this one's going to be divided by 2, which is just going to end up being divided by 4. And then that would give you equals 6.25. It's the same thing. I put it in the calculator that way. I count the steps. I take them. If there's 2 steps, I times it times 2, and it equals 4. If there's 3 steps, I times it times 2, it equals 6. So 1 step times 2 equals 2. 2 steps equals 4. 3 steps equals 6. And just put it in the calculator, and it works that way. Or you can do it, each step at a time. However works, whatever way works for you. But that kind of sums up how I work that out. Now let me show you something with this one that might come into play. Let's say, first we're going to use this one. This A times B divided by C squared equals D. All right, we have let's say 20 MR milliroentgen at, let's say 40 inches. What milliroentgen would it be at 72 inches? Now, this one is not written up here because this one is measuring radiation in the air. So the closer you get to the source, right, the more it is. This kind of goes with why you need to add distance between yourself. It's like a safety issue. Like you want to get far as away as you can, because then this number drops. So when you know that, if you know that you're measuring radiation in dry air, then you know that the further away you get, this should drop. This should be a lower number. The closer you get, it should raise. But we're at 40 inches at 20. We know we need a smaller number at 72. So I would just set it up just like using this formula, right? A is 20. 20. Oh, that looks so bad. Divided by, we need a smaller number. Smaller number goes on top. 40 divided by 72 squared. That's a weird looking thing. This is really hard, y'all, for me to hold this phone and do this. Equals what? Calculator. Boom. So we have 20 divided by 40, or times 20 times 40 divided by 72 squared equals 6.1728. So let's just say 6.17. 6.17 milliroentgens at 72 inches. All right, now here's where this formula is going to come into play. And this can work at any distance change. I'm just using milliroentgens because I kind of haven't went over it here. All right, let me do it right here. So let's say I was given 20 milliroentgens at 40 inches. And then I was given 6.17 milliroentgens and asked for the distance. Oh, that's difficult. Well, it seems like it would be difficult, but in all reality, if you just know that formula right there, or those 3, you can do any of this. I'm going to use this formula, all right? This time A, all right, let's go back down here. I want to show you something. So we have 2 values that are equal, the milliroentgen and the milliroentgen. These 2 values are together. They're with each other, but we're asked to find, we only have one distance measurement. We're asked to find the other one. So in this formula, this, and you can tell it's squared, is going to be the distance, and this is going to be the two values that we have matching. All these values, like right here, this one would be like how we done it here. This would be the milliroentgen unit, and then these would be the two distances that match squared. Same thing down here. I'm going to use this formula, the square root of a squared times b divided by c equals d. And how I would do that would be the square root. I'm going to write this down. If I lose focus, it's kind of hard for me to look at both. The square root, right? We only have one distance measurement, 40 squared, times, right? All right, now here's where it has to come into play again, though, where you have to know what's going to happen with the biggest number on top or the smallest number on top. If you have 20 milliroentgens at 40 inches and then 6 milliroentgens at smaller, then you know this distance needed to increase. It needed to get bigger. As long as you understand what's happening, and I can't stress that enough, that you really need to understand this stuff. So we know that the number needs to get bigger, right? So the way to do that is to put the bigger number on top. All right, so I would be divided by 20, or times 20 divided by 6.17 equals what? That looks weird, doesn't it? I agree, but it works. So I'm going to put the square root of 40 squared times 20. Is that right? Yeah. Divided by 6.17. Now, we've already done it one way up here. So we should know that, we should come up with about 72 inches because we're doing the same thing here, but we're just solving for this distance. So we know that it should be 72 inches. Let's see if it works. Oh, well, looky there. 72 inches. Boom. Oh, man, this is so hard. This is harder than what you think. And that's basically it, Then there's the transformer thing, but that's a whole different thing, and Don don't seem like he's really, stressing that issue. But as far as math-wise, that's all that you need to know. And let me put this here, 72 inches. Is these three formulas. Those three formulas work out everything as long as you understand what needs to happen. All right, I hope this didn't confuse y'all. If you ever want me to show you in person this, I would love to. I think it's just awesome. Or you can still continue to do the whatever over whatever equals whatever over whatever. But I find this a lot easier.